Hello, everybody. It is 1:36 p.m. Central Time on the 12th of October, 2020. It's Monday here in the United States. And check it out, fall is upon us. Just look at that really quick. It's really beautiful here and the lake, and we've got the fall colors kicking. But we are not here to talk about that. We're here to talk about seismic events, and it's been 3 days since my last update. Let me turn on the display capture so you can just see what I see a little bit better. And we're going to get into the United States in a second, where, by the way, look at this. In the last 2 days, look at that spread of earthquakes matching the craton. And the two newest earthquakes here in the Midwest, at least, right there on the New Madrid seismic zone again, right after the hurricane went over. Hot spots? Nada. At least we can't see any today. So we'll start over here in the West Pacific first, and then we'll work our way over to the United States. So deep earthquakes continue to hammer off on our letter Ds. The letter Ds are spot forecast points where we watch for new deep earthquakes to take place. For new people, the deep earthquakes are raised high off the globe for easy identification purposes. And we are actually dealing with a deep 6 this week, which means we need to watch for shallower, larger earthquake activity. One has already taken place, at least one big earthquake in the 6.7 range, which is right here, marked in a pinkish color, the big rings right at the center of the screen here. They downgraded that to 6.3, but it started out at 6.7. Anyway, it's a shallower, larger earthquake next to our deep quake. That's not all she wrote, though, I don't think. Going from that point where the pinkish colored earthquake was that I just showed you here, let's get all the others out of there, right there, spreading to the west and to the north, a series of the same sized earthquakes spreading out in both directions, to the north and to the west. And look at the magnitudes on these. They're all in the mid-range 4 to upper 4 level. We got a 4.3 here in Taiwan and a 4.7 over here right next to the tiny island of Guam, which is right here in the middle of the screen. I'll turn on our lines on the islands there. Okay, so you can see that. But it's a spread on both sides of the ridge that I've talked about for the last 7-8 years. Here, on both sides of the Izu Ridge to the east and over to the west, we go down through the Ryukyu Islands. But nonetheless, we have two earthquakes, one on each side. Again, one down here and one up here. Now, we can trace those back. There's a stepping stone path that goes back, and they meet together here, where it branches and goes over to the west. And like I said, it branched up to the north. Well, we just looked at that. These go back down to the south and funnel in together right here in Indonesia. Going to the west, same-sized earthquakes, about the same size, 4.1 to 4.8, and they're also equal distantly spaced. So let's just take it back. We get a big hammering motion coming in on the underside of the plate, and I think something like this is going on. Concentric waves coming up out of the magma, the lava, or well, magma down below the plate, and it focuses in on a single point where all the wave combines, and that's where we get our singularity or a spike that occurs down below the plate, which then hammers in on the underside of the plate, and we get a big, deep earthquake. Then I think something amazing happens. A spread starts to occur with equal distance spaced earthquakes. See these standing waves in a tank? Now you see how the waves actually, when they combine, they don't just get jostly around the tank in a chaotic form. They actually take a organized shape, and when they combine, the amplitude increases, which is the power behind the wave. And the wave gets bigger or taller, more power behind it. Now, the equal distance spacing on this is what I really think is happening here. And that's why we're getting equal distance spaced earthquakes. So first we get a hammering action in on the underside of the plate, and then that spreads out and away from the hammer point, and we get standing waves, which produce earthquakes, I think, at the highest point of the wave, but it could be at the lowest, or somewhere along the way in between. But then it spreads, and something else amazing happens. Check this out. Now, this is a wave, a standing wave, called a soliton, but it's a solitary wave in motion. So a standing wave, basically, that moves, a soliton. And it reflects off the wall and comes back. Now, look what happens here. When you introduce a second wave, and one wave intersects the other, one's coming from one way, one's coming from the other. Watch in the middle what happens to both solitons. Whoop. Like they hit a wall, they hit each other and bounce off. Each wave bounces off each other. So I want you to imagine this going on across the plate boundaries where the red lines are. Then you can understand we get same-sized earthquakes spreading out along those like they're wave tanks, and at the ends of the tank, or where they funnel back together, that's where we get our bigger earthquake activity. Now here is another deep earthquake, and it's hammering in here, just south of Japan, right in the middle of here. So we have a hammering action here, and we have a hammering action here. And I believe that's sending out waves in all directions, just like this one would. And where they combine, where the waves meet, that's where we get the standing waves, and we get the same-sized earthquakes breaking out like it's in a wave tank. Going over to the west, we get into Myanmar, India with a 5.4. And what's right there? Take a look. Do you see the red line, the plate boundary? What you're going to see is that the earthquakes spread across and go all the way over to Europe with the same sized activity over the last 48 hours. So a 5.4 here, and then look, a cluster all the way across Pakistan, Afghanistan, South Iran, and North Iran in the middle of the Caspian Sea. And it's 5.0. Then, over to the west, also a 5.2 to 5.3, a 5.0 range earthquake. So it's 3 sets of 5s, with this one first, this one second, this one third. So across the whole region, though, look, from here to here to here, following the inside portion, or the northern side of the portion of the plate boundaries, between all the plates. But it can be traced back to here, where we have a stepping stone path of 4s that go back all the way to where our hammer point began. Same with the up to the north, up in Japan, for instance, where the hammer point started. It goes up around, and we have the same sized earthquakes going over into Alaska in the last 48 hours. Last 2 to 3 days. The pinkish colored earthquakes from 2 days ago. Whitish colored earthquakes are from today. The whitish colored earthquakes are filling in the middle point between the pinkish colored earthquakes, which struck a day ago. As we get over towards Europe, like I said, north of Iran, right here in the Caspian Sea, 5 struck just on the north side of our arrow. And then just east of Crete, right next to Rhodes, a big swarm outbreak took place. But this is just the bigger earthquake activity. Let's take it down all the way. Look what happened. Romania got hit with some earthquake activity going up into the mid-range to low-end 3. And the same sized earthquake struck the coast of Normandy. En français, tremblement de terre. There it is. Ah, oui. Okay, or you could say, a sailboat. It's an English channel. And there it is. A 3.0. Sip my coffee, hold on. Good day to you, sir. I said good day. 3.0 English channel, coast of Normandy. And we can trace it back. That's within the magnitude of what we're looking for. I was looking for up to 4.0 range. But we'll take a 3 and a 2.9. Also, same sized over on the eastern edge of the European craton. And then right in the middle, you don't see it now because the Europeans reported it yesterday. It's over 50 earthquakes deep on the feed. By the way, the European feed is only 50 earthquakes long, so we only see usually the day's worth of quakes. Anyway, right here yesterday, a 3 struck right here in the middle, right next to Norcia, which was the south point of our warned area from Florence to Norcia. But it's all a magnitude under what I was looking for. I was looking for 4.0 range, and instead 3.0 range came in. But it was a direct hit at Norcia, direct hit at the coast of Normandy in France, and then over to the east in Romania. Again, you can see it here. Let me get all the smaller earthquakes out of there so you can really see this like little triangulation of 3.0s. You got to imagine a 3 right here where the ring is that struck yesterday, okay? You can go look it up if you don't know that it struck, but again, it was right on at 3.0. Why does that matter? Because that's the same size that struck at the coast of France and the same size that struck on the eastern edge of the European craton. That's what we were looking for. It's just, like I said, a magnitude under, which means there's still a magnitude worth of energy trapped in the plate, and a new 5 has now been introduced into the system. So this means we're about to see another round of earthquakes take place across Europe, and this time it's going to be where the rings overlap. So I probably should warn all of Italy, but let's warn South Italy next to Campobasso, where the rings overlap east of Etna. Etna's been going. And let's go up and look into Poland for a new release in the 4-ish range. Since a new 5 has been pushed in, 4 should go across the plate. There's already a magnitude's worth of energy still trapped in the plate. Then, to top it all off, we should see a new 5 strike out here next to the Azores, as well as a new 5, or a pretty noticeable swarm, break out around Iceland. North Pole, look, last week I was looking for the North Pole to get hit. Instead, the Arctic Circle got hit right here. At Greenland, actually, west of Svalbard, which is more rare. So I'll say it, North Pole didn't move last week. We'll just keep an eye on it. Not that it matters. There's nobody up there right now, I don't think. But the magnitude should be about, if it strikes at the North Pole, that'll be the only iffy point on this. If it strikes at the North Pole, it should be about the same size that strikes in Iceland and at the Azores. Okay, now let's jump back across and go all the way over to South America because a new 6 struck right here. You see how it says 5.9? It was 6 all day long after the earthquake struck. And then somebody got a hold of somebody and they did some calculations and brought it down to a 5.9. Hey, psst, hey, I got a 0.9 for you over here. Take a look. It's good stuff. A 5.9. It's a 5.9. And, you know, it's like, you guys ever, you know how they reduce retail prices to $5.99 and $4.99? They do that on Twitch, by the way. $4.99 for a subscription. Just a little bit less than 5, you know, just a little bit less shocking. Well, anyway, we'll call it a 6, and it's right on the arrow. But where did it come from? We just trace it back, follow the arrow right back to here. And what happened right here 3 or 4 days ago? The big, deep 6. Let's get all the others out of there. Here it is, raised high off the globe in red, right in the middle of our letter D. This came hammering in first. Remember what I told you about the hammering action on the underside of the plate? First it comes hammering in, then it spreads out in all directions following those red lines and dropping off same-sized earthquakes all the way along the way. And those red lines, again, are these. But you'll notice that the USGS doesn't have anything marked on their map here going across the Pacific. While I have 2 giant arrows pointing over to where we see energy spread to the north and to the south. And then we go back to the USGS map and you'll see to the north we have a fracture zone and a plate boundary. And to the south we have a fracture zone and a plate boundary. So when we leverage in on the underside over here, energy spreads across and it tries to equally distribute to the north and to the south. Well, in this case, look, it's on the southern arrow only. While up to the north, look at this. Wait for this to refresh. Up to the north, it's a huge outbreak across Central America. Well, wait a second, going back to the map here, if we have energy in the 6.0 range spreading out across down to the south, and we have energy going up here, north of the plate boundary fracture zone here, and it's just pushing all of the plate into Central America, which is then going to push over into the Caribbean. So, to the south, 6, and at the tail end, right down here where the 6 points in, think of this 6 coming across here, 5.9, whatever. 5.7, 5.9. Actually, USGS has it at 5.9. Europeans, or no, is it 2 separate quakes? It's 2 separate quakes, 5.7 and 5.9. So think of this like 2 trains coming across a bridge, and the bridge is vibrating. But at the end of the bridge, we have a mountain that the trains are going to hit. And, of course, if it's a train versus a mountain, guess who's going to win? The mountain. The train is going to brake and go around or try to go underneath or around or over whatever obstacle that's in its way. Now, we're not talking about a train, but we're talking about a force or a power coming across, and when it hits here, it tends to go down, around, and underneath and come up here. But first, when it impacts, we get a big outbreak, and it breaks out in between our current sets of earthquakes. So look where all the rings overlap. North Chile. Well, where all the rings overlap, we watch for something larger. So again, if this is a train coming across a bridge and the vibrations of the bridge indicate a 6 across the energy coming across, then it's going to be something bigger than that that comes in at the middle point. Now there's another middle point, big open silent zone across this whole area, and we had some volcanic activity last week right in here. Forgot the name of it. Oh boy. Never on the list. Not Villarrica. Boy. The name escapes me, but you guys can look it up. Last week, Chile, small sporadic puffs and steam emissions from this volcano that never erupts normally. Never erupted. Yeah, right. Okay, so up to the north, we have a giant open silent zone across all of Ecuador, all of Colombia, all of Panama, all of Costa Rica. Then, like I said, an outbreak or a cluster across Central America. That goes across South Mexico, going down across Guatemala, and you see the red lines here that go over to the east. Now, I issued a warning for Cayman Islands. The Cayman Island right in here, which you can barely see. It's just like a little speck. And I actually could probably show it to you on the USGS map here. Here is Cayman Island. And we had warned there, and now a new earthquake struck right next to it in the low to mid-range 4 level. That's within the magnitude of what we're looking for. So if I'm looking for up to a 5 and a mid-range 4 or low-end 4 comes in, that's within the magnitude. So now that the Cayman Island area has been struck, the spot really that was struck is right next to this stair-step boundary that goes up to the north. And like I said, we have a bunch of pressure and energy that's been coming in here, and it's coming across from all the way over here, and it's coming straight across. So 6.0 down to the south, or greater, equals 6.0 to the north. So we should look for a new outbreak across the coast of Mexico, probably right here in between the sets of current quakes. That means Guatemala and El Salvador on the south side of the plate boundary here, where they come together. Now, I have not looked at the Volcanic Ash Advisory Center today. Let's go take a look really quick, see if anybody new is on there. Dukono in Indonesia, regular suspect. Suwanee-Zajima is back in South Japan with a 5,000-foot eye blast. Sanjay in Ecuador, regular suspect. Same with Reventador in Ecuador. Sabancaya in Peru. Fuego in Guatemala. And remember Guatemala, I just talked about it. Right where the two red lines come together on the plate boundary. Keep going down the list. All we're doing is looking for new additions. Nevados del Ruiz has some kind of seismic signatures, but nothing observed on satellite yet. That's in Colombia. Several times, volcanic ash was observed earlier in the day. I'll show you where that is. Kurimsky in Russia, up in Kamchatka. That goes into yesterday, of course. And that's pretty low on the list but Fuego's on there over and over again. Fuego is right here in Guatemala, where the two lines come together, where all the seismic activity is taking place, and we would expect a new 6-ish type earthquake to break out in here, in between our current sets of earthquakes, where they all overlap. That means South Mexico, El Salvador, and further to the south down to Costa Rica and Nicaragua. But right in the middle is where I would look. And then over to the east, now that a mid-range 4 has come rolling in on the plate boundary at the fracture zone next to Cayman Island, you can check Cayman Island off the list. But then over to the east now, where the rings overlap, Jamaica, Cuba, Haiti. So I would look where the rings overlap, and I would look for something just a little bit bigger than the 4.3. Energy's coming across. Then Puerto Rico, to top it all off, Puerto Rico is going to get hit again. Right back here at the swarm location, since it's already swarming, it's going to get hit. And the magnitude should go up by 2-fold. So go from 2s up to 4s. That's a 100-fold increase in power. Another way to look at it. So we should go up into the upper 4, maybe even the same size as what's going on here right now. Could go up into the 5 range. So I have to warn you for upper 4 to 5 range at Puerto Rico and mid-range 4 level next to Jamaica and Cuba, going as far east as the tip of Haiti. But you see where the rings overlap. Well, that's where we're watching, the middle point. Now, I said I would show you where Nevados del Ruiz is. Right in here. The middle western central portion of Colombia. Kind of right next to where our arrows are. And it's, you'll notice, the middle of the open silent zone. It's no coincidence there. Let's go back to the USGS map and show it to you this way. Right in the middle of here. Now, of course, energy's coming across. We know it. It's being pushed into the edge of the plate here, which is going to transfer over to Puerto Rico. Okay, now, United States. Mainland U.S., lower 48, Alaska, and Hawaii, which I haven't talked about in a while. I'm going to have to talk about Hawaii because we have a new outbreak taking place in Hawaii. And people noticing that, contacting me from Hawaii, asking what's going on in Hawaii. Okay, we'll talk about that towards the end of the update here, but equal-sized earthquakes, like I said, going across the plate boundaries, everywhere where I talked about, where these standing waves spread out to. One more time, in the tank, each equal-sized wave representing an earthquake, and as it moves, it drops off new earthquakes as the wave fills in the middle point of the open valley between the previous wave. So each wave basically cuts itself in half, and that's where we get new earthquakes. And then the middle point, where it reflects back, if it reflects back in many cases, at that middle point where the waves reflect, let's show it to you again. One wave reflects off the other wave. It's just so amazing. And that takes place and a new larger earthquake strikes at the middle point between the sets of quakes. The combined total of both waves at the middle, if you will. But then it spreads further and it goes over into the edge of the plate. In the United States, for instance, let me make sure you guys can see all this, goes into the edge of the North American craton, guys. And if you don't know about the craton, it's just a geologist's word to describe the interior portion of a plate. All plates are made up of cratons. Some plates are made up of several cratons. But the rough outline of our North American craton, you can see here from many diagrams and books and so forth. But you can see also that the earthquakes are matching the edge of the crate over the last, let's say the last 4 days. And maybe I need to turn the rings down just a little bit so you can see this a little bit. But starting up in the northwest, you can see a definitive line, and I'll say that several times now in the update, a line of quakes coming out of Montana, going down to southeast Idaho, jumping across southern central Colorado, and then going down through Texas, making a bend through Texas, back into Oklahoma, back over to the New Madrid seismic zone where it makes an N-shaped bend in the plate. Then it goes up the East Coast, and the earthquakes match that, the craton edge. And it goes from 4s on the West Coast down to 3s in the Midwest, over to 2s on the East Coast. That's no coincidence. This happens on a weekly basis this way. And the bigger push that comes in on the West Coast, the more activity that spreads out across the edge of the craton. There is a weak point between the interior portion of the craton and the exterior portion of the craton, and that's this purple portion called the deformed craton. Now you'll notice, look out on the West Coast, where the deformed craton meets the stable craton, the brown portion. Yellowstone is there. Up to the northwest, Montana, right down through it, right down through the middle of the park. Then, out on the west coast, California's border with Nevada, the other spot where the purple intersects, but it intersects with the green, right? Right there is a supervolcano. So these supervolcanoes form along where the edges of the cratons are, and it's not just the United States that way. It's amazing. So now I need to turn off the magnitudes because in the last few days, there's just been so many earthquakes. Look at this. Do you see how this makes almost a ring around the Pacific Northwest? Well, really, that ring is, again, on that purple portion of the craton, going out to the accretionary belt or the coastal plain over to the west coast, basically. Now, it connects over to Texas, and it's a perfect match. It really is. So this is the last 2 to 3 days worth of earthquakes, and the rings tell us the size of the quakes, but I can turn the magnitudes back on. 0s, 1s, 2s, with a few 3s mixed in. Now, we need to look at the last 24 hours worth of earthquakes, 0.0 and greater. The last day, we need to see what's been moving in the U.S., and that gives us a good idea of what's getting ready to move in the U.S. And I told everybody with this New Madrid seismic zone hotspot issue that started to take place this week, I told everybody I was going to be watching for the rest of the week, maybe even longer in the Midwest, for the potential of a large earthquake to strike. But in this case, we don't have any other previous examples to go on in the Midwest for flare-off events like that, plus a hurricane just dropped an entire hurricane's worth of rain on top of the area. Don't know what to make out of that. An earthquake swarm already struck there. And in the last day, you see it. 24 hours worth of earthquakes now. Hold on, let's just make sure this is the right feed. Last day, 0.0 and greater. Here in the Midwest, on the New Madrid seismic zone, the swarm carries on. The number of earthquakes is small, and the magnitudes behind it are lower now. A few days ago, it was 2.6 to 2.8. Now it's down in the low end 2 and 1s, but it's still focused. The only difference is now it's on the Tennessee side of the border instead of over on the Arkansas side of the border. You see that? It's moved slightly. The earthquake swarm has. Now back over to the west, same number, about 3 or 4 different earthquakes striking in Oklahoma. This is extremely low compared to where we normally are with Oklahoma and the earthquake activity. So the amount on the New Madrid and the amount in Oklahoma right now are low. Going back over to the west, nothing across Texas, Nothing across Colorado. Going back up to the west-northwest, Yellowstone has gone down to a single earthquake. One earthquake. So that's low compared to where it was. Over to the west, last night, a 3 struck right in the middle of the arrow, right on the edge of the craton again, going down through Idaho. So that's the biggest of the bunch. Going back down across Utah, one lone outbreak here on our arrow going across Utah, and Magna, Utah, just north of it on the Wasatch of 0.1. This is all extremely low. So I would say, if we're going to use surfing analogy on this, we are between waves. We are getting ready to see, and I still am holding to my forecast on this, several noteworthy earthquake events out on the West Coast, 4 to 5 of which should be across California, one of which could still take place out in the Pacific Northwest, which I didn't even issue a forecast for, but we'll get into that in a second. We have to talk about the Pacific Northwest in relation to all this silence downstream. All of a sudden, in the past several days, an episodic tremor slip, an ETS, has now been confirmed to be taking place across Washington and Oregon and Vancouver Island, but mainly across Washington. As a matter of fact, I think they only said Washington, but we know it goes not just in Washington. Let's show you where we're talking about. Here in the Pacific Northwest, Washington, Oregon, Northern California, Vancouver Island. And we need to go over and consult a different map now. We're going to go to the tremor map from the Pacific Northwest Seismic Network. And this is showing us yesterday's tremors, which you see 614. You'll see they're all focused in here along pretty much the whole state of Washington, going from the Strait of Juan de Fuca all the way south of Tacoma, right down next to the border with Oregon. What's our cutoff town here? Vader. No way. Is that right? No way. The cutoff point is at Vader. And that's right at the state line almost. Anyway, Vader, Washington. Oh man, let me get the Professor V. I've called him Professor Vader. Oh my goodness. That is so ironic. Okay. So, all these hundreds of little red dots, all the way across Washington, they do have magnitudes assigned to them. But I want you to think of these as vibrations as the plate is shifting from the Juan de Fuca fracture zone out here to the west. So one more time, here's Washington, Oregon, Northern California, Vancouver. But the jagged zigzag line out here is the Juan de Fuca fracture zone. And this portion over here to the west belongs to the Pacific plate. So the jagged edges belong to the greater Pacific plate right next to the Juan de Fuca. Energy comes in from out here, and these are like arrows pointing into spots which move. And from here all the way down to the axial seamount where there's a notch into the edge of the plate boundary, the fracture zone. You see it. Over here on the tremor map, all these tremors taking place on land. So if we go over to the west from here, go over to Google Earth now. We're going to go off the coast of Washington. So the tremors go right down to Vader, right down in here. But parallel to that, if we just go due west, quite literally due west, without varying even to the north or to the south even a little bit, we're right at a place called the axial seamount, which if we go back and compare on the USGS map, that's this notch right here. That's where the volcano erupted under water back in 2015. The big eruption. So we're breaking out on the edge of the axial seamount, right across from it, parallel to it, and then we go all the way up to where this points in up to the north in the Strait of Juan de Fuca. All of Washington is shifting. That's as of last night. Let's go back one day to the 10th, or well now 2 days ago. Look at this, 817. But do you notice anything? Well, down to the south, of course, in southwest Oregon, in northern California. But going back to the USGS map now, look. Tremor outbreak here, tremor outbreak here. This is the other arrow pointing right into where the tremors are taking place a day ago, down to the south, the southern arm of the Juan de Fuca. Southern arm of the Juan de Fuca on land, pushing in, creating shifting. Think of this down below, think of this up above, like a bathtub, where this is the bottom of the bathtub, and this is the side of the bathtub that slopes up, and we have shifting and vibrating up here as the energy and tension comes in from down below and pushes up. Now, when it pushes up, it also pushes up, out, and away. And we get pushes that go across the craton. But right now, it's all focused right in here. And the flow has basically been cut off. The flow out across the craton the tension is building now. That I would think of this more like a pinball machine now, where you're pulling the spring back and it hasn't been let go yet. So the silence takes place, and then the push is going to come in. And you'll know it when it comes in. It'll be from low surf to surf's up, get your boards. Hate to use that analogy, but it's one that out here on the West Coast, a lot of people understand that we're between waves right now. That there's going to be some major swells that come in out of this, which is the wave tank generator, if you will, that's pushing in. And it is almost coiled like a spring. If you think of this three-dimensionally, again, we're looking down on it two-dimensionally, but it goes up and down, and I would imagine it even curls maybe through the plate. That this is where the spring loading comes in, and then it pushes into the plate, and we get the shifting that goes in downstream from where the pushes come in. Okay? Now that takes me into the rest of the earthquakes, because we just have a little few up to the north. And I don't even know if these are our earthquakes. They might be explosions for all I know. Let's go look. Snoqualmie, Washington. One lone quake up here at Snoqualmie. And over to the east, what's this one? Enfiat, Washington, and we're up inside of the mountains. These are right next to where those fires took place. Now, up to the north, I think that's a quarry. Let's just go see. Yeah, this one's an explosion next to a big open pit mine quarry. Now, I'm going to keep the tremor map open. This is now going back to last night's into today. Today's tremors across the West Coast, where an episodic tremor slip is happening, an ETS, a slow slip, as the professionals call it. And that just means that the Juan de Fuca is pushing into the plate, and the plate and the Juan de Fuca are shifting past each other, hence all the vibrations, and they call it an episodic tremor slip when it reaches a certain threshold of number of hundreds into the thousands. And in the past 2 days, we are certainly into now the thousands of tremors that are taking place up here. So what do you think that's going to do to the rest of the plate? I mean, do you think it's... now, that's a rhetorical question. We know what happens when we put tension into anything. It tries to transfer across whatever you're putting the tension into or the power into. And in this case, it's going to go and follow the weak points in the plate. Now that gets us into the rest of the earthquakes that struck downstream from where the tension's building and coming into the plate. Over to the edge of the craton, just a trickle. Again, if this was normally a flowing river that's going over to the New Madrid seismic zone at least, going up the east coast to Maine in this case in the past 2 days, following the edge of the craton all the way up the east coast, the whole plate is saturated now. That takes it back to here. If the whole plate's saturated and now it goes quiet, a new push should come in from the northwest and go down following these. The plate boundaries to the south, and you see which way the faults take across the California-Nevada border. They're pretty much going in the same direction. They look like a funnel going in all directions pointing down to here, which is Ridgecrest down here to the south, Owens Valley, and Long Valley Caldera supervolcano there. But again, this is like a giant funnel all pointing in to right there, isn't it? I mean, again, that's not an exaggeration on my part. It really is coming in down this way, and they're all pointing in down this way, and this is like our center point for all of this to go out and away from, but it's being fed from somewhere. And you see my arrows, which way they go. And compared to the edge of the craton, again, it's being fed from the northwest, guys. It's coming down in from the northwest. And you can see it go across the coast in today's quakes. Starting here up next to Eureka, California, too. Going down across Clear Lake Volcano in Geysers, California here, which we know what's there. There's a volcano called the Geysers, and humans have drilled in there. Then we go down through the Bay Area, down next to Mount Diablo. Wait a second, because look, here's the red line. The earthquakes are following this, going down across Geysers right here at Clear Lake, and then going down across to Hayward here, just south of the Bay Area next to Mount Diablo. And it's coming in from up here, which is shifting, like I said, across Washington at least, and certainly a day ago in southwest Oregon and northern California. So 3 states worth of shifting going on here, and a line of quakes flowing out down to the south. But this is small too, and these all struck last night going into this morning. Since last night, let's get 12 hours worth of earthquakes on here. This is pretty much since last night. So this is low too. we would expect dozens and dozens of earthquakes coming down from the north, and we only have a little stack of zeros at geysers and some ones going down that thick red line that I showed you here, coming out of the Juan de Fuca. How could all this be shifting with thousands of small tremors, and we don't have anything really flowing down to the south or over to the east? Like a flow has been cut off on a river. It's all back up here right now, getting ready to spring out on us in two directions. One down through California, my forecast stands. Two noteworthy earthquakes up north, two central south, and a fifth possible down all the way in Southern California. But like I said, we have to wait to the end of the week for me to really slam dunk on that final fifth. But we should have two up to the north. One at Eureka, one in the Bay Area. Two central south. We should have one at the California-Nevada border, one on the Owens Valley, just north of Ridgecrest. So that's the four earthquakes we're going to look for that are going to be in the upper 4 to low 5 range. Then the fifth and final possible earthquake at the end of this coming week or start of this next week, that it would be down here in Southern California from LA to San Diego with the combined total of all four coming in. So it depends on what size strike up here. If they're all 5s, then it'll be an upper 5 that strikes in Southern California. If they're all 4s, then it'll be a 5 that strikes in Southern California. Okay? So I'm all hinging it on this up here to the north, which is the slow slip shifting that's putting power into the plate, and it's confirmed now it's an ETS. And we saw in the past a few examples. A 7.7 earthquake struck right after an ETS took place across Vancouver. Let me remind you, the day that Hurricane Sandy came ashore on the East Coast for the first landfall back in 2011. I think it was 2011. I still have to go look it up. 2011, 2012. Hurricane Sandy, Frankenstorm, it was right around this time. It was like October of whatever. And when that hurricane came in, that same day, 7.7 earthquake struck right here, Queen Charlotte Sound and the Hecate Strait. It caused a small tsunami and drained out the hot springs along the coast. Now that followed about a 2-week long episodic tremor slip. It went for 2 weeks, the slow slip did. Up here, all across Vancouver Island, Japanese professionals from NHK News, seismologists, came over to interview the people from the Pacific Northwest Seismic Network and the USGS about the episodic tremor slip taking place because they thought it might lead to a large earthquake like Japan did earlier that year in March with the big megaquake. There was a ETS taking place on the coast of Japan right before the big earthquake hit. Anyway, the Japanese researchers came over. There were thousands of these little red dots appearing all the way across Vancouver Island, just like what we see today in Washington. It was just across Vancouver. And they interviewed all the professionals, every professional. Oh, there's no relation between large earthquakes and episodic tremor slips. Oh, that was just chance and coincidence over in Japan. That we need to study this more. We know of no relation. The Japanese researchers recorded all that, and they packed up and left. The next day after they left, because they had the dates of their interviews in their NHK interview, the day after they left, guess what happened? The slow slip stopped completely. Okay? Well, you think it's over. Of course, the professionals are right then. Of course, the slow slip stopped. Within a few days of that, I want to say it was 5 days? 4 days? 4 or 5 days, not a week. Within 4 or 5 days of the professionals leaving and the slow slip stopped, the 7.7 earthquake struck right here on the north side of the whole zone that slipped. So it slipped for 3 weeks, 2 to 3 weeks, with thousands of tremors. Researchers came from around the world. Professionals went on the record saying ETSs don't cause large earthquakes. Then, boom, 7.7 earthquake struck right here within days after that. So is that going to happen again? Well, I can already tell you, it's already happened again. We've had smaller ETS events, which have resulted in 5s down to the south, on the edge of the Juan de Fuca to the south, right off the coast of California, and big-time movement across the edge of the Craton. It just stands to reason. You push on the plate, it's going to go somewhere. And it follows the weak points in the plate, which in this case, we get back over to California, where the rest of the earthquakes are coming down along the coast and going over to the California-Nevada border. So that gets me into what's happening at the California-Nevada border. Look where our earthquakes are centered to the north. We have a 2.0 here next to Lake Tahoe, King Vale, California. There is something at this location that's worthy of note and worthy of interest and no professional ever found. Let me show it to you. Took years of me watching this, and then finally I noticed it. This. So let me turn off all my borders and labels. And let's turn off the roads. There we are. This thing, actually, I probably should turn off the volcanoes too. Just remember where the volcanoes are. But turning off the place marks. This giant oval shape in between Lake Tahoe and Pyramid Lake. Now, this thing's lined with volcanoes. It gets hit with earthquakes around the outside edge and go right into the middle of it. We had fires break out all the way around this thing and in the middle of it. And on both sides of the giant oval shape, on one side to the south, we have Steamboat Springs Volcanic Field that's been tapped into with all its geothermal turbines, and they built subdivisions on top of the volcanic field there, Steamboat Springs. But the same distance almost to the north of this giant oval, we have another geothermal feature that just hasn't been tapped into. These are the fumaroles and geyser field at the Needles at Pyramid Lake. And they actually go down into the water there. But so on both sides of the giant oval, we have two large geothermal fields. It's lined with volcanoes, gets hit with earthquakes around the outside edge in the middle, and fires break around the outside edge in the middle. I think it's a supervolcano, caldera, from a long time ago that's been missed. Somebody needs to get in there and do VLF measurements and figure out earth-penetrating tomography. Because look at this one. This one's a smaller version. This one's bigger. But right down here at the California-Nevada border, that's the verified supervolcano Long Valley, with 1,000 cubic kilometers of melt down below. It too has a bunch of volcanoes around the outside edge. It too gets hit with earthquakes around the outside edge and in the middle. And it too has fires and hotspots that keep breaking out on the side of it. Now there's a third one. So I think that one is to the north. We know this one is at the center, right here. They're both the same shape and size and facing the same direction almost. But down to the south, there's one more that I think is, and that's here. We can see 3/4 of it, and again, they're lined with volcanoes in their own right. Golden Trout Creek, marked by the Smithsonian, Red Hill, two the same size and shape. Same with Templeton Mountain and Monachi Mountain, which I've been pronouncing Monash Mountain, but it's apparently Monachi. Two the same size and shape, and Brown Mountain in the middle, but it makes a crescent. And that crescent can be connected over to the west, over to Soda Butte, and down to the south, which if I back it out, you might be able to see this. This round, bulging laccolith, which is an intrusion into the plate of magma. So this thing is, look, it's the same size and shape as the supervolcano here. And to top it all off, hotspots and fires in the middle and the outside edge, including going down to Camp Nelson right here. And earthquakes that come around the outside edge and go into the middle of it. So that's 3 giant oval shapes across California and Nevada's border, starting up between Lake Tahoe, going down to the confirmed supervolcano in the middle, and going down to what I think is another one down to the south. But they all match this and this, the edge of the craton, the deformed edge. And that's where the faults are, all the way across, and they point back down to the supervolcano in the center of it all, right here. Again, that's Long Valley right here, the supervolcano, the confirmed one at the center. That's where all the faults point down to. And back over to. Once we get south of it, that's why I have an arrow over to the east. Once we get south of Long Valley, look what all the faults do. Do you see? They start to make a U shape or a bend that goes down through Arizona, and they don't have many marked here over to the east, do they? Well, again, if they did, well, they do actually here. Look, you can kind of see it now on their map, hopefully. And it matches the edge of the craton where they have it marked. They're going to end up, you know what you're going to end up seeing, is a bunch of faults. Once they map it all, they come down, go down, over to the east, back up, over and up, back and around, back and down, and you're going to see it match the arrows. Because that's the way the earthquakes flow across the plate. Path of least resistance. And it starts on the west coast, taking me back up to the push that started. And of course, once we get down to Central California, we're at the supervolcano itself. And look, on both sides of the border, we have outbreaks taking place. One on the east side over at Monte Cristo Hills. Look at this line of quakes. It's spreading. It's reaching over closer over to the California-Nevada border. On the California side of the border, that's the supervolcano I just showed you, Long Valley Caldera. But right across diagonal up to the east-northeast, look what's there. Let me show you. Here's the supervolcano. We have an outbreak of earthquakes right inside of it. And we have a line of quakes extending from here all the way down to here. From the northeast down to the southwest. From Monte Cristo Hills Volcanic Center down to the Volcanic Hills Butte volcanoes. There's a 12-mile-long surface fissure fracture which formed. And a 6.5 earthquake that accompanied that. A break in the ground going northwest to southeast. And the earthquakes match that. Now it's spreading in 3 directions from there. So this line goes over to 3 points. And those 3 points spread, if we carry that on over to the east. 1 point goes up to Mono Lake. Central point goes down here towards Long Valley. And third point goes down towards the south tip, or the north tip of the Owens Valley. Let me bring it in this way. We go across, over, across, and down. And that's 3 prongs on a line of quakes that's spreading as energy is clearly going to be coming in from the northwest, already is. It's going to excite things. Let me put it this way. Another way to look at this. If you live on the west coast right now, look at the Craton Edge one more time. And now look at the earthquakes coming in from the northwest. The number of earthquakes should go through the roof first. We should see the number of earthquakes increase. The frequency. As the plate is vibrating up here to the north, it's going to start to vibrate and shift and transfer that energy into the plate. That's when we know it's coming. And when it gets here, when the energy actually arrives, you'll see it go just from the number of earthquakes increasing to the magnitudes increasing, like somebody turning up the volume on a stereo system to the point where the speakers start to vibrate and almost break. Because that's where we are up in the northwest. We're not at the break point yet. Those thousands of tremors are the sign that something's getting ready to release. It's being pushed into the plate now. The plate can only take so much tension, and when it does take that tension in, it goes out and away and down from where the tension came in. Going back to 2011, following the slow slip, there was a series of earthquakes that went across the Craton. It was in the 4 range. But the professionals, and well, I didn't think it was going to just disappear, but the professionals all thought it was over and no release would happen up out in the ocean. So I'm talking about on land now with all those 5s that should come across California. But in the end, when the slow slip finally stops, it could go on for another 2 weeks. We've seen it go on for 2 to 3 weeks before. We're like 3 days in. Maybe 4, well, actually 5 days in if you include the first 2 days of a couple hundred. We're like 5 days in on an ETS that can last for a couple weeks. And at the end of the ETS, or towards the end, somewhere during the ETS, we can see a big quake out here where the fracture zones come in, where the power's coming from. So not only do we have to look for earthquakes to spread out and away from the spot that's currently shifting with all the hundreds of tremors, but in the end, there should be a final compensation on that comes in from where the energy came in from. And we know it's coming in from the north. It's preferencing the north. We can see it preferencing the north over the past 2 days, where all these hundreds and hundreds of tremors are today, or last night. Go back a day, and they're all centered to the north for the most part anyway. We can go back a day before that to the 9th. Look at this. I mean, again, it's centered to the north for the most part, with just like a handful down on the south arm of the Juan de Fuca. Go back to the day before that, again, it's preference to the north with just a little bit in Oregon. Go back to the 7th, and like I said, about 5 days ago it started with 510. The day before that, 538. Well, that's 6 days. Hold on. How many days has this been going on? Okay, it started in earnest on the 4th and 5th. This is really where it started. The 4th and the 5th. And it went from, on the 4th, 190 into 190, leveled off at 190, then went boom up the next day to 500, then the next day 500, then the next day 5. So it's been 8 days of it already. It's been shifting for 8 days, or building tension for 8 days. Now, in the last 8 days, other things have taken place, haven't they? The hot spots on the New Madrid seismic zone. Something else that took place over the past few days. The dying out of the fires on the West Coast, including California. Yeah, I know you got some rain, but... So, let's carry on. The entire creeping section of the San Andreas remember what I said about the flow being cut off on this river, the seismic flow, if you will. That on the Craton edge, it's been cut off. It's building up here. It's going to release. But down to the south, same thing going on. The flow's been cut off to the creeping section of the San Andreas, and I don't like to see it go quiet like this. It normally shifts a lot with hundreds of small earthquakes per month. So if you go several days, or at least a full day, without anything, not even a zero, extending from Mount Diablo all the way on the east side of Monterey Bay, all the way down here to Lompoc, the whole San Andreas has gone quiet. That's not good. The flow has been cut off, like I said, and that's going to release, and when it does, we will fill in at the middle open points at all these spots. That's another forecast that we can get into at just probably in the next couple days, which is after the break takes place, after the fives come in, what to look for. So I'm still going to look for it between our sets of quakes here, Eureka, and between our sets of quakes here, I guess that's Bay Area and Napa Valley. 2 sets of upper 4s to 5.0 range quakes. Same with Central and Southern California. Here, right between our sets of quakes, between Monte Cristo Hills and the supervolcano, I would look for upper 4 to 5.0 range, maybe even bigger. But I have to keep it within the magnitude, so 5-ish range. And here, the middle point between the supervolcano and Ridgecrest, which is Owens Valley. So that's 4 noteworthy quakes across California. Like I said, then and down to the south, LA to San Diego. The combined total of everything coming down. Look, you can't shift up here without it moving all the way down to Southern California. There's been so many times that we've seen slow slips take place, ETSs, with all the hundreds of tremors. And then down to the south, where the red lines come in from the Pacific Northwest. Go back to the USGS map here really quick. So we shift up here, and then down here we really start to break with earthquake activity. While there's thousands of tremors up here, it has a combined total that goes down to the south. And we get breaks with earthquakes down to the south, while you get thousands of tremors and vibrations up to the north. Then follow it all by a big quake as compensation on the edge of the area that pushed you to begin with. So it's like actually 3 stages. Or 4, really. First, the push comes in that starts the whole plate shifting with all the little red dots, all the little vibrations. So first, the plate starts to move. Then we see it translate into the plate. Then we see earthquake spread out across the area. Then the area that ultimately pushed it, there's compensation next to it, and we get a big quake that's the sum total of everything that moved. And then it starts over. It starts building again. And we take a big push that comes in from somewhere across the rest of the planet, and it starts to cycle over. 1 lone earthquake out here. Wait. Not 1, 3. 2 over to the east in Eastern California, and 1 that just popped on here, next to the nuclear test sites. I don't even know if we should go look it up. Might get in trouble. Let's go to Furnace Creek. I think it gets its name here not from volcanism. I think it gets it because it's a Death Valley type situation at this spot, but let's go see. It could be a Furnace Creek volcanic field for some reason. No. Oh wait, we're right next to Ryan Craters. Okay. An old geothermal pumping operation. They used to have this geothermed at some point in the past. They came out, scraped out the pads, and they've removed the pipeline since. There's nothing there now, but Ryan Craters, right next to it. No doubt about it. We're right at the Ryan Craters. And we're on both sides of it. Again, I mean, we're right like a mile on each side of Ryan Craters Volcanic Complex. Now let's go over and see if this is at a nuclear test site, 7.1 kilometers deep. They're not doing nukes there now, don't worry, guys. But there are man-made faults all around this area from fractures from all the underground nuke testing they did. So where are the nuke sites, you might ask? Here, this is Doomtown, Operation Rise Line. And let me just turn on... Wait, hold on. We'll just turn on the Google Earth community here. Operation Rise Line. They blew away that town on the surface. These are all the underground nuke test sites. So all these hundreds of craters that are across the valley here. What's this one called? U.S. Nuke Operation Gundy Prime. 20.8 kilotons. Or is that 208? No, that's 20.8. It's just missing the point. May 9th, 1963. Gundy Prime. Never heard of it. What's this one? I mean, we've got names on all of them. You guys can come in and read more. U.S. nuke Operation Cerise, November 18th, 1966, 7 kilotons. Well, there's hundreds of them there, and we're right next to it with our man-made faults that don't show a sign that they're doing any blasting. It's just a weak point. It's proof that when Mother Nature exerts power into the plate, it just seeks out the weak points, whether it's a drill point or a volcano, or in this case, a nuke test site, a blast in the plate. But it's proof that energy is transferring across the plate and seeking out these weak points. And we can trace it all back. We can, again, just connect the dots back up to the west-northwest, where we don't have any earthquakes reported across Oregon, by the way. Speaking of those diagonal lines of quakes, going northwest to southeast, just like what I was talking about up here in northwest California. And just like connecting from up here at this supervolcano to this supervolcano, down to this supervolcano. We get down to the south even further, and we have a diagonal line going across Ridgecrest and a diagonal line going across Southern California. And they're all going to the northwest to southeast. There is no disputing that. Let's go back over to the USGS plate boundary map. It's matching where the plate boundaries and faults are, of course. But why do they all go in that direction? They all point back up to here. That's pushing it to break it apart and then spread across the plate following the craton edges. And then you can just trace it down and follow the number of earthquakes and the size. They're all the same size. As more energy is introduced into the plate, of course, the number of earthquakes go up and the size of the earthquakes go up. And I'm looking for it to go up to 5 because of what's going on up here with the thousands of tremors and shifting that's happening up here on the Juan de Fuca. It's going to push on the rest of the plate, and you're going to get 2 up north, 2 down south, and then the 5th all the way down to the south. Most likely. So nuke test sites are getting hit, Ryan craters are getting hit, and this line of quakes, let's just go right in the middle of it this time. This is Ridgecrest, California, China Lake, the experimental test facility. I don't think they're doing any experiments that deep. And certainly they're not going to do them on themselves because the people that live there got jostled around with a 7.0 earthquake a year ago. Right here. See what this earthquake is? A fissure, a ground crack formed starting right about, let me find it. Hold on. Right here. See this splotch? It's actually an old mound of lava rock, but anyway. Starting right there and going to the west-northwest 25 miles, a crack in the ground formed. And right next to that crack in the ground, look what we got. These are all lava flows at Volcano Peak. There's like 14 different eruptive points here. These are black lava flows that go out into China Lake. And that crack in the ground went all the way up here and fizzled out somewhere right around in here. But then, right here, that's where the earthquakes have formed and started at the north side of here, which is Kozo Volcanic Field. Zooming in on it, geothermal pumping operations at Devil's Kitchen, as they call this place. Devil's Kitchen. So it's been drilled, the volcanic field has been drilled, and that's where the earthquakes start. They go down through the east side of Volcano Peak, and they dead end into the lava mountains. So from volcano to volcano. And let me show you the lava mountains. Starts up here, Kozo Volcanic Field. Surface fissure fracture goes all the way down here to the east-southeast, and here's the lava mountains. The earthquakes putter out on the Garlock Fault, which goes in this direction, northwest to southeast, or I'm sorry, northeast to southwest, as the earthquakes come in from northwest to southeast. Goes down and hits here. Once it hits into the Garlock, it exerts force across the Mojave. And look at the USGS map. Look what goes across the Mojave and which way it goes. Well, the faults now go northwest to southeast, just like the earthquakes. So once it hits the Garlock is just a spread point where equal distribution spreads out to the south and to the east. And hence we go over to the east on the edge of the craton, and we go down across the Mojave. Is this a quarry blast out there? I think it is. Hold on. Wait. They don't have it marked as a blast. Huh. It's Boron, California, though. This is where they always do all that blasting every day. Could it just be a man-made fault from all the blasting? Let's go see. If we're right at the quarry, I'm just going to label it as a mislabeled quarry blast. Yeah, I mean, look, guys. We're right on the edge. Whether you want to think it's a quarry blast or whether it's just a fault that broke from all that quarrying, it's just one earthquake. Let's go look up the rest down to the east-southeast. We have a lone 1.6. Like I said, the rest of California has gone quiet. But the location here, Castaic, California. Ding, ding, ding. Hello. Hey, everybody. Wake the hell up. Castaic, California. Dude, really? How about the fires that broke out here? But do you guys remember what happened when we found Castaic, California to begin with? Let me take you back like 2.5 months or something, 3 months ago. An earthquake struck right here. I zoomed in on it, and I said, hey, an earthquake by a dam. I'm like, uh-oh, that's interesting. But I zoomed in more on the earthquake, and I saw these. All of these. Let me zoom in and just get a good view on one that has a side shadow view. What you should be able to see, even at this height, are all the oil wells at this location, all the drill points right next to the dam. And the drill points go all the way over to the west, out here into the mountains, where we have a whole bunch of pumps right next to each other. They go all over the mountains here. So an earthquake struck there. I zoom in, find the oil pumping operations there. I say, what the heck? Who the hell's in charge of that operation? You remember that, right? Then, the next day, sudden fires on a clear day broke out all the way around Castaic Lake. The Castaic fires. I have marked August 2nd, 2 months ago. Well, we have a new earthquake there. Does that mean we're going to see a new fire break out there? Are there any hotspots there now? GOES is not detecting any fire signatures. This is from August, that one I marked, but no new fire signatures across anywhere down here in California. Stand corrected. We have 2 hotspot signatures now showing up in Southern California last night. 458 Kelvin, about 600 degrees Fahrenheit, and 504 Kelvin, about 650, something like that, 600, 650. 2 hotspots showing up there in the mountains. What's our nearest towns? North of Duarte, just out here in the back country. Right there, last night, 2 hotspots. Those are the only 2 in the entire area. So going back up here to Castaic Lake, a new earthquake. We cannot ignore it. Look out in case any new hotspots show up. Furthermore, down to the east-southeast. Let's go look up these small little events over in East LA. Now, I have a warning. Oh, wait. Oh, my God. Of all the places, Glen Avon, California. Oh, my. Well, I got to tell you the story. Oh, man, this is a heck of a story, guys. So we have to go back to last spring. It was like May into June of 2019. And a series of earthquakes broke out right here at a place called Glen Avon. Right at the pinnacle tip of this little mountain range. These are water tanks, but somewhere right down in here. And enough earthquakes broke out there. It was several hundred small earthquakes broke out at the location that the professionals came out and acknowledged the earthquake swarm at Glen Avon. Said there was talk on social media about it. I didn't even really talk about it. I just kind of glanced over it and didn't really mention it. But they came out and said there was talk on social media. It got me interested. I said, what are they talking about? They said, it didn't mean anything. It's totally normal. Happens all the time. And that's when I knew something was up, because we don't always have earthquake swarms down in Southern California. And, not hundreds and hundreds of them stacked on one top of each other like that. So Glen Avon was the name. I then went and got the name and went and looked it up, and I went to go look for drill points. And of course, it's all subdivisions, and we don't have anything around here except for some landfills, and we got a quarry right here. And it got me interested. I wanted to find out if there were any old pumping operations that were here. Because Southern California in particular had tens of thousands of oil wells back in the late 1800s, early 1900s. Before they made this into residential, a lot of it was all the way down to the coast too. I mean, it's just like so much you wouldn't even believe it. People sent me pictures around this area where they had hundreds of wells. I couldn't remember if it was particularly Glen Avon, so I went and did the research. What I found was that there was exploratory drilling that was done here by a guy named J.R. Kosenki. Kosanke. And J.R. Kosanke drilled all the way around this range, right through here, going right over to where they have a quarry now. And he only found minimal amounts of oil. But instead of finding oil, according to all his paperwork and all the stuff he filed with the state in the, 1920s, is when he was doing this, he found a large amount of gold. So what he did was he capped it off with these wood caps and put 4 bags of concrete on each way down in the well, a couple hundred feet down, and then filled it in with dirt. He reported the gold finding to the officials and moved on because he was looking for oil. And that was in the 20s, the late 20s. And then World War II happened in late 1930s, early 40s. By the end of World War II, big defense companies were authorized to come out here and dump industrial acids into the ground for some reason at this spot where Kosanke drilled and found the gold. Now, guess what you need to break apart the rock to get the gold flakes out of the rock? Industrial acid. Anyway, they start dumping this stuff in the ground in the late 1940s. Throughout the 1950s and 60s, they finally stopped, but they got caught, and they had to clean it up, you see. So what did they do? They came in and they start quarrying. Okay, so that's the history on the location that was drilled exploratory several hundred feet deep, found the gold, dumped the acid, leave it for decades, come back, quarried out, and that's where we are now. And an earthquake swarm breaks out there, and the professionals come out and say it's not related to anything. Why even cover out, say it's not, why even talk about it then? All right, okay. Something happened after that. So Glen Avon had the swarm at the end of spring last year. Following that up, over here, at a place called the La Brea Tar Pits. You may have seen these in movies. You may have heard of the La Brea Tar Pits. The La Brea Tar Pits suddenly surged and overflowed. And not only that, they came up underneath the streets all the way around the area. And it was like in some kind of movie. And it came up on the out of the manholes. And it was coming up and spreading out in the sewers. And people tried to say it was something normal. The media then came out and said, this is after the Glen Avon swarm. Within a couple, like the same week, all of a sudden the tar pit surged all the way around here. Then, to top it off, a couple days after that, North LA, which is right here, this is Los Angeles. Just so you know, this is LA. North LA, somewhere in here, in between here and downtown, somewhere right up in here, the sewer system exploded with sudden natural gas in the sewer system that exploded and blew the manhole cover sky high, like 50 feet high. And that happened. So first, the Glen Avon swarm next to the old drill points. Then the tar pits overflowed. Then the natural gas explosion in the sewer system. Then on July 4th, July 3rd and 4th, 2 different things happened. A 6.5 and a 7.0 earthquake struck right back up here on the back side of the whole thing that got pushed. So all the explosions happened down here, and the tar pits overflowed, and the earthquakes broke out. But the big earthquake took place right back up here on the back side of the Garlock, where all the energy had come rolling in from up to the north. So now we have a new earthquake down at Glen Avon. I told you it's a heck of a story. That was last year. And by the way, 2 days before the big earthquake hit, the biggest earthquake in 20 years in California, we issued the warning to be on watch for a 7. And then the 7 hit. And we had warned from here down to here, to the Central Valley up to Bay Area. And the earthquake hit here, the largest in 20 years in California. And we warned for 7, and a 7 hit. Okay, now, Southern California, let's wrap this up. A diagonal line of earthquakes that spreads from the San Andreas down to the Imperial Fault, but it pretty much goes on the western side of Salton Sea. I'll show it to you this way. This is the San Andreas, this is the San Jacinto, and the earthquakes go from here, down across, down to here. And this is our southernmost warned point. I'm warning everywhere from East LA, along the San Jacinto, to east of San Diego for the final earthquake to strike. by the end of this coming week as the energy transfers in from the slow slip. But the slow slip, like I said, can go on for 2 weeks. We've seen it go on for 2 to 3 weeks before. I don't think we've seen it go on for a month. I don't know. Again, don't quote me on that. I don't know how long slow slips normally last up here in the Northwest, other than to say we've seen them go for a couple weeks at least and then stop. Then followed by big earthquake activity. And, of course, while it's shifting, noteworthy earthquake activity. So big earthquakes after, noteworthy earthquakes during. What's the difference between a big earthquake and a noteworthy earthquake? That's terminology I'm using, but I would say the difference would be the difference between 4s and 5s, which are enough to knock things off shelves and get your attention, and upper 5s and 6s and bigger 7s that are enough to really cause damage and tsunami activity, like in 2011 with that earthquake up here at the Hecate Strait. Let me just get the year on that, because it's going to bother the heck out of me. When was Hurricane Sandy? That's just going to answer it easier than finding the quake. 2012. Okay, it was in 2012. Okay, so in 2012, when the 7.7 earthquake struck here, the same day that Hurricane Sandy was coming ashore on the East Coast, it was up on the north side of the area that shifted. Is it going to happen again? I hope not. I really hope not. But the flow right now has been cut off. I think anybody who's been paying attention over the last several days has seen that this has dropped off in the last 24 hours. Which then takes me back to the Craton, which is going to be pushed, and already is. And I haven't even checked the hotspots. I probably should go check and see if there are any, because the hurricane should be clearing out by now, and there are still earthquakes that are taking place down on the New Madrid seismic zone, and we don't really have anything else to go on. One more time, the earthquakes have gone all the way up to Quebec and New York. By the way, Pennsylvania had its earthquake, and the earthquake's in Ohio, so it's all the way across the edge of the Craton already. The whole plate is saturated, and I don't know if there's any more heat releases taking place. Let's go take a look. Let's go over to College of DuPage, get a sip of my coffee while it's loading, and let's turn on the shortwave infrared. By the way, a lot of people contacting me. A couple of well-known YouTube video makers have been giving me shout-outs and mentioning us. Also, we got mentioned on Coast to Coast and Alex Jones. But one video maker raised a good point. I think that was the Florida Marquis. Sorry if I'm butchering your name. I should go look it up. But mentioned something about a laser in communications or taking out drones. And people were saying, Dutch, I don't see how that could be a laser. And I think he might be onto something. Because high-powered lasers, in particular, can strip electrons in the atmosphere and ionosphere, but coming out of space, basically. Think of scuffing your feet across the carpet. This is the best analogy I can use. Scuffing your feet across a carpet. You pick up energy inside of you, like a battery or a capacitor. And then you're insulated with your shoes or your socks or whatever. And then you go touch something, like a metal doorknob. And all that energy discharges out of you, right? Okay. Now the beam itself is scuffing its feet across the carpet of the atmosphere. And the beam can build up electrons in it on top of the transmission in the power that's already put into the beam. And it can reflect. Those electrons reflect radar. They reflect other types of radio waves. So let's say it's a high-power shortwave beam. It can generate a glow on shortwave, of course. But that glow can reflect on radar and reflect a microwave beam, even though it's from high frequency. So it also stands to reason that a laser could do the same thing. A high-power laser, like Michio Kaku talked about for laser weather modification, that can strip electrons in the atmosphere, and that lightning can follow that. That's according to Michio Kaku. I don't want to play the ABC or CBS interview. I don't want to get the copyright for that. So let's go take a look. Let's go look at the hotspots. Whatever it was, whether it's a drone shoot out, it's going from space or from the base. And it's visible on a civilian system, which is not good if it's our system. They need to fix that immediately and make it not visible. Or adjust the weather radar so we can't see it. So we do have some hotspots appearing again right here. And we just got a hurricane's worth of rain dumped on the area. There is 1-2 right now in southern Missouri going down into Arkansas. I bet we can go see it on Google Earth on the GOES fire detection. So we do have hotspots now. Oh yeah, look, it's bright red. It's just appeared right here. So they just dumped a hurricane's worth of rain now, came right up here through Arkansas and dumped all across Arkansas, going down into Louisiana. Nobody can tell me that this is some kind of fire from a farmer's field. There's no way. And that's right next to where the earthquakes took place. Success, Arkansas is right up here along the border, 3 miles south of the border. So now we have a new hotspot marked in red. Right now, what's the temperature on this? Unknown meters squared and unknown fire Kelvin yet. Up here in Missouri, we also have detections from last night. Last night and this morning, here and here. Can't be chance, can't be coincidence. I wonder if there's any more. Oh, look, we've got more down in Louisiana Bayou. Let's go zoom in on some of these spots because there were oil wells at some of these locations the last time I zoomed in. There really were. They were like right next to it too. Yeah, here's an oil well right here. Oil and gas well, fracking. Where they can burn off, they'll burn off the gas. Look at that. Wow. Okay, well guys, we've got hot spots in the bayou here. Let's go back up here and see if there's more. Nobody can say it's from the hurricane because this was happening before the hurricane. Look, here's another one. And this is a pipeline. That's a pipeline, guys. So they have flare burn-off apparatus on the pipelines too in case there's overpressure. Let's go up here to the north. Is there another one? It's a fire detection signal right here. Oh, yeah. Hold on. Yeah, big fracking operation here. Huge. All those are different wells. Let's go zoom in on this spot. Is there more? There's the pipeline to it. Well, pipeline to it is just as suspect as the frack well itself. Yeah. Well, there it is. So we have hot spots appearing across the area, from oil wells down to the south, and up here to the north, where there are no oil wells, on the New Madrid seismic zone. Going back down across the edge of the Craton, going down through Texas, same thing going on. Look, it matches the Craton to the south. It makes that bend down to the south and goes back up to the west side of Texas, where our hotspots are marked in these reds and oranges. And then it makes a curl and goes right up here into New Mexico, where I don't see anything marked. But once we get back up into Colorado, there's another one at the Colorado border, on the edge of the Craton in central Colorado. Are there pumping operations here? Let's go zoom in and see. We have a farm field. Oh, wait, nope. No, it's farm field. Farm field. Don't discount it all. There could be frac ops inside of here. Okay, that's for storing water. Alamosa. Maxeyville. The Great Sand Dunes. Okay, well that's really interesting. Here at the Great Sand Dunes, just to the south, we have large pumping operations. That's far enough away we can't. But this is a huge magnetite deposit there. In case you don't know. My God. And it carries on up to the northwest. It really does, following the edge of the Craton. We have new hotspot detection signatures across Washington and Oregon right now. Going on right now. Let's go over and check up in the northwest. Localized sectors, Washington and Oregon. We'll go down to the Washington-Oregon border region. They're being detected right now on GOES. We'll take this up to the most current image and see if it shows on here. We're looking in shortwave, so hopefully we'll be able to see it. A lot of cloud cover. Rain and snow up here, by the way. I'm not seeing it. I am not seeing it. Let's go in and look at just the state of Washington. They just showed up in the past few minutes, so it would be in the last frames here. Let's go see. Last few frames. I don't see anything showing up, guys. There shouldn't be anything showing up. No hotspots should be showing up right now. Let's go see what's there. Let's just start with this one right here. Just a rocky, look at this. Just a rocky, barren hillside with tuftage on it, layers of lava Do you see these layers, how they overflow on top of each other? That's tuftage from ancient lava flows. There's no farm field there. There's no anything there. It's a rocky hillside. There's another one down here. Let's go see. Wallowa in the Wallowa-Whitman National Forest. And we have some very strange features on the ground, but no farmers, no anything for that. Not to mention it rained and snowed up here. Here's Kennewick. Wait. Kennewick? Hot spots are around Kennewick, guys. Now, Kennewick is where the Hanford Nuclear Waste Processing Facility is. Here's a hot spot. Here's a hot spot. And here's a hot spot. And here's a hot spot. And Hanford is right here with the LIGO gravity wave sensing station, but all the nuclear material stored here with the old experimental reactors that they broke down and left the caskets on. Hot spots around there. All popping up right now as I'm talking. The red ones. Okay, here at the California-Nevada border region. Just nothing out in the middle of nowhere. Desert. Look, this is our vegetation. You see how sparse the trees are? Do you see that? It's just desert. You're be kidding me, man. Look, I mean, let's just zoom in and show you without the red there. That's just rock with a few sparsely spaced trees. That's where our hot spots are right now. They're all popping off right now. I need to go back over and just look again. Let's hit refresh on this. And it could just be very small. I mean, each one's just a single detection. Not even an acre wide. But in the middle of nowhere, right after they have rain and everything, yeah, there's nothing showing up yet. That's amazing. I'm glad we get to catch this real time. So now we know what to look for. You see where the red hotspots are up here. We have to look for something up here. We have to look for new fires to break out up here, even though there's nothing showing up right now. They're hotspots suddenly randomly showing up across, not randomly. If you look at their distribution, they are not random. Not at all. Hey, Southern California's got them right now. We now have them down in Southern California on both sides of Salton Sea. Hotspots detection right now. Live, 2:59 p.m. Central Time on the 12th of October, 2020. Let's go in and see what we... This is the spot where the 2 earthquakes struck last week. It's spot on. North side of Salton Sea, that is the fault. We talked about this at length in my update. Let's go open the fault zone map. The 2 earthquakes that were there, I talked about them. I used them as an example as energy when it normally goes down and around the San Andreas. Right here. Here. Yeah. Look. Here's the San Andreas. Here's Salton Sea, north side. Let's go back over and look at the hotspots. Salton Sea, north side, San Andreas, 2 hotspots within the past few. And then on the west side, over on the San Jacinto, additionally, a new hotspot showing up within the past few minutes. Also, here east of San Diego, 2 hotspots showing up all of a sudden. And look at the hillsides here. Wow, covered in houses. So there, and there across Southern California today. Let's go in and look at Southern California on the College of DuPage weather satellite. Let's go down to sub-regional sectors of Southern California. And to see, is it like storming down there or anything to cause a fire? Let's go to natural color fire. No, it's clear day. Completely clear day, not a cloud in the sky. We have fires up at the Central California region next to the supervolcano. But down south, look, just clears a bell all day up to current. Now let's go over to shortwave infrared and go into a localized sector down in Southern California where these all are appearing. They're all appearing around Salton Sea. Let's just see. Time now is 1 p.m. Up, down in Southern California, south of Salton Sea. Look at that. Flicker, flicker. That's not one of the solar farms there, guys. Do we have any more? Up. Right here. It's hard to see. And right down here, we have 2. I can't see the ones on the west side of Salton Sea, but look, there's a geothermal pumping operation at this spot south of Salton Sea. And I can prove that to you. Let's show it to you. South of Salton Sea, right down in here. See where it says Brawley and Westmoreland? That's where the earthquake swarm took place. Brawley, Westmoreland, right next to it. And here, zooming in, there's Brawley. And here's our geothermal pumping operations that go out to the drill points. And it's getting the steam, the heat, from the volcano here, which is Salton Buttes. We have 2 hotspots on the north side on the San Andreas. We have a hotspot on the west side on the San Jacinto, out in the desert. Quite literally out in the desert, with sparse vegetation and not a thing from man in miles on a clear day. And then 2 more down here next to San Diego, which just is wow. These are from yesterday, these orange colors, so we'll leave those out. Just looking for any more. Looking for any more. We have a couple across into Arizona. Couple in Arizona now. Okay, well, again, this takes me into the West Coast, the plate shifting. I'm glad I took the time to look it up. Up here in Washington, hotspots are appearing. Up here in Oregon, hotspots are appearing. Down here in California, hotspots are appearing. All in the past couple hours at the most. Going over to the east following the edge of the craton. We have hotspots back on the New Madrid seismic zone. Here. And down in Louisiana, which I trace back to oil wells. What do you want to bet we go back to oil wells in Kansas too if you go up here on these reds up here to the north? What do you want to bet? You guys can go look it up. You don't have to take my word for it. You guys go look for yourself. This takes me back to the earthquakes, though, matching the craton perfectly, going all the way up to Maine and New Brunswick and southeast Quebec, and going all the way back down through the south, all the way to the west coast, where the pushes come in from the northwest, where the Juan de Fuca is shifting. And we're looking for 5.0 range activity or greater to come rolling into California with 4 separate quakes across California and a 5th one down to the south. The 6th arguable earthquake will happen either during or end of the slow slip, and it'll likely be on one of 2 sides of the area that's slipping. And what spot is slipping? Already showed it to you several times. Washington. So we will either be on the north side or the south side. What's on the north side? I've already showed it to you several times. Here, the spot that got hit in 2012, the 7.7. South side is down here next to Eureka. The chances are, I would say, if a big earthquake's going to strike, it will follow the trajectory of the plate, which puts it down to California and over to the east. So 5's hitting California. That means 4's are going to come to Oklahoma. That means New Madrid seismic zone will be charged again. It's still charged. It's moving now. A quake is struck there in the day, and a new hotspot is struck there within the day, after a hurricane's worth of rain was dumped on the location. You guys need to have an earthquake plan. I'm serious. You need to know what to do when an earthquake strikes. Same for out here in Hawaii, which I said I was going to talk about. Hawaii, aloha. Look at this. Hey, I do recall we've mentioned this before, that a line of quakes going around Hawaii's southern coast, the Big Island, going out to Loihi, and going back around to the Middle East Rift Zone. It's making almost like a circle shape following where these dark depressions are. Then, up at the top, or to the west-northwest, the top of the whole island, top of Mauna Loa, we have an outbreak taking place. I'm going to pull the earthquakes at Mauna Loa. Then that'll give us a bearing for the rest of these that go down along the coast and over to the east. You'll see predominance of them right here along here. Look how it makes like a pinnacle bend across the south tip of the island. There's something there right at the pinnacle tip, but I'll show it to you. Everybody in Hawaii already knows about what's here. I'm just doing this for everybody else, I guess. We have a series of volcanoes there. But there's magma chambers that feed the volcanoes that pinnacle tip comes in on. So we have an outbreak at the top of Mauna Loa up here, referenced and shown by the earthquakes here on the northwest side. Then, like I said, it comes up to a pinnacle shape. And that pinnacle shape, let's pull the coordinates for it. We have a little stack of earthquakes right up in there. I'll pull the coordinates and put them in on Google Earth. Volcano Hawaii is the triangulated coordinate location, if I could say it. But look, we are going down inside of the crater at Kilauea now, guys. Right at the highest point at the top of the Middle East Rift Zone. We are inside the crater. It's been a minute since we've had a swarm inside of Kilauea crater. And it's been a year and a half since I said that I thought it would be about a year for there to be a new blast coming out of the crater at Kilauea. When I see a line of quakes pointing up to Kilauea's crater, and the spots that it spreads out to, over to the west, Mauna Loa. Down to the southwest, what's there? Out in the ocean, right off the coast. Let's show you. So we just came from Mauna Loa, we go over to Kilauea, where it's all centered. We go down to the southwest and we get out here. Well, we're at the base or the side of Lo'ihi, an undersea mount that's rising. But the magma chamber connects in, I think, to Mauna Loa, personally. Could connect into the Middle East Rift Zone. Nonetheless, line of quakes here, line of quakes here, line of quakes here, going along the coast. And that's the Middle East Rift Zone, connecting into Mauna Loa and connecting down to Lo'ihi. But the new change here is the swarm outbreak inside of this pit. This used to be an actual level covered in lava, dark black lava flows, and had a lava lake inside of it. That lava lake drained out, left a huge open tunnel tube in the ground, which then started to collapse because apparently the lava, or the magma inside coming up to the surface of the lava, was holding up the tube. And it collapsed in. And then it drained out. And when it drained out, the whole Middle East Rift Zone drained out. Over here on the east side of the island. And we can look at this at an angle. We should look at this at an angle so you can understand it. Okay, now we're looking down on the side of Hawaii. And the Middle East Rift Zone here started to drain out. All of this started to drain out over on the lowest point on land, right down by Pahoa. And it flowed out and around, but it went down, down, down. As it drained out, guess what happened up top? The top started to collapse. Down, down, down. And it went down like almost 2,000 feet. So it got this low, the whole thing collapsed, then the caldera collapsed. So first this collapsed, then the outside edge started to collapse out. And that's what we're seeing here today. So the top of the magma chamber is now smaller. It's collapsed down by 2,000 feet. 2,000 feet smaller up top here. So the energy or the power that's coming into there is from the magma. And the magma has less of an area to go into. It's smaller of a space. It's going to displace out to the other volcanoes. Whatever would normally go up into the Middle East Rift Zone has to go somewhere. And so it's going out to Lo'ihi, and it's going up to Mauna Loa. The magma itself, probably. Again, it's a guess on my part, but the earthquakes accompanying that. And hence the earthquakes are all centered around the area that's filling and doesn't have anywhere to go. So it's spreading down here, spreading over here. But doesn't that mean that the Middle East Rift Zone is recharging? That's what it means. And I'm sorry if you hear a cat meowing in the background. It means that this is all refilling with magma. It's probably already full, and it's reaching over to the others. But it'll get to a point where the energy and the energy tied to the magma coming in will cause a new eruption, either over at Lo'ihi, up at Mauna Loa, back at Kilauea. I would think that it would go back at Kilauea because of all the previous times it's done this. There's blasts and there's flows, and there's blasts and there's flows. The blast happens as it recharges and it gets to a point where it's overflowing with pressure and power. Magma down below is pushing up. The flows happen when a push comes in and flares up the magma all the way, and it comes up to the surface and flows out. So there's two different pressure events that take place. One is a blast from building pressure that can't escape. The other is a lot of pressure that comes in and causes a flow. We're on the edge of the blast portion of this, which makes these blast craters that you see. They look like a crater in the ground from some kind of meteorite hitting, but it's reverse. It's up instead of down. So what's going to happen? Well, I was wrong on my 1 year estimate. It's a year and a half. Here we are. We're a year and a half. And now Kilauea is starting to move. 6 months off. Dang it. Well, we'll see. We'll have to wait and see. But if it carries on with the number of earthquakes, you'll know it. They won't hesitate to warn you guys. Plus, you also have to keep in mind, there's a lake that's formed inside of Kilauea's crater now. So there's water weight on top of that can mix with the heat that would come up from any kind of volcanic release. And that could also lead to a phreatic steam burst of some kind. But I think it'll lead to more of what we would expect. A big boom from out of the inside of the center of the crater, and there will be a warning of a couple days as the seismic activity starts to reflect that. And right now, we're on the edge of that. If I were to see any more take place here, I would tell my viewers to start to watch for the potential of an explosion to come out of the center or around Kilauea. That takes me back to the start of the whole update. The big deep earthquake event that's taking place. The deep 6, the deep 5s, the deep 4s. They're all in a short period of time in the matter of a couple days. It's just like we went from a little snare drum roll and we went back up to beating on the toms and on the bass drum. And when we go up with the deep earthquakes, that takes me back to the hammering action coming in on the underside of the plate. When there's more hammering action coming in on the underside of the plate, that power comes up through the plate and spreads out through the plate and tries to equalize following the plate boundaries, and that takes us back to the plate boundary map, the red lines, where you see all the earthquakes pop off, equal distantly spaced as the waves try to spread out across the region. And if you guys are curious more, I'd be happy to tell you to go check out my How to Forecast an Earthquake video. Oh wait, did I just close Earthquake 3D? How to Forecast an Earthquake video. And you guys should go check that out. It's an hour-long explanation on the fundamental principles behind how to forecast an earthquake. And if you want to repeat the test, do it yourself, start forecasting yourself, well, it's all there. I mean, it explains, for instance, why I issued a warning for the English Channel on the coast of Normandy for 3 to 4.0 activity to strike. We can trace it back to here, where the push came from, which is why I issued the warning. We can trace that back all the way to here, where the pushes come out of the West Pacific. And we can trace that back all the way over to here, where the pushes come up from down below the plate. Comes up, spreads out, and away. And we can watch it spread across the whole plate, following the craton edges and following the red lines of the plate boundaries. So this earthquake plan thing I keep talking about, you should have an emergency kit that has clothes and shoes and first aid and sanitation and also some batteries, also a way to power your mobile phone, a way to charge it. Should also have those needs met for people in your family. Food and water for a couple days at least, and something that's easy to carry around. So in case you get displaced outside, you can grab it at a moment's notice. And also where you keep it. You should keep it somewhere nearby where you're going to be making your exit, which means you have to pre-plan where you're going to exit your structure. Have the emergency kit and the emergency bag there. Might even want to have a couple of them for your family and for other uses. So you'll think of great things to put into your emergency kit. I'm just reminding you to do it. Do it. And then you can use it also for evacuations, for fires or floods, or even for severe weather. Big severe weather is coming through, knocks out power. Well, at least you know where your emergency kit is. So you can go get your flashlight. You don't have to fumble through drawers and those kind of things. Speaking of fumbling through drawers, you want to have in your emergency kit an extra ID or a way of identifying yourself somehow. You might also want to have, if you have it, extra cash. You might want to have an extra debit card, a birth certificate, copy of that. So, you could go get a new ID somewhere else. But those kind of basic things, insurance cards, if you have anything worth insuring, you would keep that all into your emergency kit, copies of it. And then that way, it's way less of a cluster when you have to exit and go somewhere. I will be back if anything else goes down. So please take the time to develop your kits now. And like I said, if anything big hits, I'll come back on and do an update. I'm going to upload this over on YouTube. That's right, back on YouTube. Word up and much love to everybody who's watching over on Twitch, everybody who's watching on Facebook. Thank you guys for sharing the info. I am 100% positive that the info has gotten out around the world. And about the DEW beams and the observations that are going on weather satellites, it's just an unintended consequence of multiple systems where frequencies are overlapping, or in this case, electrons are reflecting other frequencies, and it becomes visible on an unintended system. But that's amazing that we're at that level in the level of technology that's taking place. I'm not good amazing either, in my opinion. I'm not exactly pro directed energy anything. Okay, guys, see you later. Peace out.